Guys, today we're going to talk about taking fractional pieces of numbers. So as you can notice, over here on the left side of my screen, I have some smiley faces. Now, I know how many I have because I can count the columns and the rows. So I have 1, 2, 3, 4, 5, 6 columns and 1, 2, 3 rows. Now, that tells me that the total number of smiley faces is just going to be 6 times 3, which is 18. So I have 18 total smiley faces here. Now, what I want to do today is I want to look at some fractional pieces of these smiley faces. So the first thing I'm going to do is I'm going to take a look at just this first row here. Now, if we box in that first row out of 3, you're going to notice that we can kind of look at this as a couple different fractions. We can either call this 1/3 because it is literally boxing in 1 out of 3 rows. Another possibility for a fraction we can call this is we can count all the smiley faces and we can count just the ones in the box. So 1, 2, 3, 4, 5, 6. And we can say that this could also be 6/18. Now, keep in mind that 1/3 and 6/18 are exactly the same. Okay. Now, if I were to expand my box a little bit, now covering 2 of those rows, I could say this fraction would be 2/3, and I could also call it 12/18 because now we're covering 2 out of the 3 rows, and we also have boxed in 12 out of the 18 smiley faces. All right, now let's look at what would happen if we went in the opposite direction. So let's assume for a second that we were looking at something that looked like this. Now we're looking at the columns rather than the rows. So in this case, I am looking at one of the columns out of a total of, as you can see here, there's a total of 6. So one fraction I can say here is 1/6 because we have boxed in 1 out of 6 columns. Or I could also say 1, 2, 3/18. And again, these two things are worth exactly the same amount. We could either say 1/6 or 3/18, and either of those are going to be the same. Again, if I were to expand my box over a little bit here, now instead of 1/6, I would have 2/6. And I could, in this case, because now I have 6 of those smiley faces boxed in, I could say that is going to be the same as 6/18, which is also, if we looked at this a little more carefully and saw that if we had a box here, a box here, and a box here, that would be all of them. We could also say this is also going to be the same as 1/3. So we start to see a lot of fractional pieces repeating here. Now, here's how this can be quite helpful. What we're actually doing here is we're multiplying fractional parts, or we're taking fractions of a larger number. Now, what I mean by that, let's go back to this original piece that we had here. What I want to think about is I want to think about taking fractional pieces of larger whole numbers. So in this case, we have 18 smiley faces. Now, we've already established that this top row is 1/3 of the total number of smiley faces. Now, one way that we can take fractional pieces of smiley faces or fractional pieces of any whole numbers is we can think about if I were to take 18 and I were to split them into 3 equal parts, that kind of sounds like 18 divided by 3, which is exactly what we're doing in this case. We're taking 18 wholes and we're splitting it up into 3 equal parts, which is 6. And as we can see here, we have 1, 2, 3, 4, 5, 6 smiley faces. Same idea. If we were to go look at this piece, this would represent 1/6 of 18. And in this case, that would be like taking my 18 wholes and splitting it up into 6 equal parts. And you can see here that there are 3 smiley faces in each part. Now, this works again if we go across, which is splitting it into sixths, or if we split it into rows, which would be thirds. Now, I do want to say it also works if I were to look at two rows. So we know that 1/3 of 18, we already said, was 6. So if we're looking at 2/3 of 18, the same thing kind of works here, where we're thinking, okay, we're going to split 18 into 3 equal parts, which is going to be 6. But then we're going to take 2 of those parts. So a really easy way to figure this out would then be to take that 6 and multiply by 2, which gives me 12. So 2/3 of 18 is going to give me a total of 12. Now, could we make this work for other fractions? Of course. Let's say, for instance, I wanted to know what 1/4 of 12 was. Using this same strategy, we're thinking about taking 12 wholes and splitting it into 4 equal parts. In other words, I'm thinking, what is 12 divided by 4? And that is 3. And if you think about that, if I were to take 3, 3, 3, and 3, that would be splitting up into 4 parts, and just taking one of those would be 3. So 1/4 of 12 is 3. Same idea. If I were to say, what is 2/4 of 12? Again, I would be taking 12, splitting it into 4 parts, which is 3. But now I want 2 of those parts, which is now 3, 3, 3, and 3. But now I'm going to take 2 of those parts, which 3 plus 3 is 6. So if I were to take 2/4 of 12, or in other words, 2/4 is a half of 12, I would come up with 6. Now, the last thing I do want you to know is what we're actually doing here is we are multiplying. We are multiplying fractions. So when I say 2/4 of 12, that is the same thing as saying 2/4 times 12. So think about these pieces, think about these pictures when you are trying to take fractional pieces of whole numbers.